All right. So I'll tell you what the Rawkode Academy is first. It's a website. You can go to rawkode.academy, no surprises here. And the plan is to populate this with the last 4 years of my life, which has been making developer education videos on YouTube. I want to get stuff off of YouTube and onto my own platform. As part of that process, I have severely over-engineered it. Feel free to check out the content at rawkode.live. It's just a short link to YouTube. And everything that I'm going to show you is open source. So it's all on the github.com/Rawkode Academy/Rawkode Academy. It is a mono repository full of fun and interesting experiments, hopefully. Now, if anyone has done cloud native development before, this is a small snapshot of the architecture. There, are and will be more services. Yeah, definitely over engineering. I mean, I think that's my middle name at this point. But I wanted to push cloud native forward. I feel like, I've been in the Kubernetes space now for about 9 years, helping people build microservices. But I wanted to take it a step further to the point where my microservice, and again, this is in the context of YouTube, right? So we're talking about people, shows, episodes, technologies, and guests on a show or hosts on a show, etc. And so, okay, these are services, they're not really micro. So what if we break these up and each of those services has its own data model, read model, and write model, which are independent services, to the point where another example, the profile service is actually I can't say that, database less. Try saying that 4 times fast. It's actually an aggregation service, which means that I don't need to do database migrations. So while a person's profile may have a forename and a surname, if I decide to store location, I spin up a new microservice with 1 column. If I want to store your age, I spin up a new microservice with 1 column. And we use some pretty interesting GraphQL technologies to do these aggregations and keep performing. So that's the architecture, is where we're taking the platform. It's still early days, but Restate has become a critical component now, and I'm going to kind of talk about why and how we're using it. Now, the challenges with this architecture are, the GraphQL read model is wonderful. It works great. Nothing to solve there. But we have to write data into the system. And I've given you a GraphQL query here. It's a very simple one, but actually solving it is complex. Because we can create a show with a name, but the minute we add the hosts to it, well, do those hosts exist? And do we have to create them? And, fortunately, we can have multiple mutations where we say, okay, let's create a person at the same time. They can be used as a reference in the show. But we don't want either of these mutations to fail and have to run it again and wait for the eventual consistency to happen to make this work. And imagine writing your profile. If there's a mutation called update profiles, that's actually 12 or plus write requests to 12 different microservices. Secondly, I adopted libSQL for everything. So there's no Postgres, there's no MySQL, there's no CockroachDB. It's all SQLite locally, and it's all libSQL in the cloud. Now, this is a wonderful technology, but SQLite is limited intentionally. So, we don't have the ability to do change data capture across our services and react to changes. And I've got a few examples of that further on, but we do need this. It's very important. Now, we could do this with triggers, but obviously you're limited with triggers. And then are those going to be based on HTTP requests where we don't have the resiliency if one of those requests were to fail? We also have this dual write approach, which we've all done at some point over the last 20 years. I know I have done it many times, which is we fake our CDC by just saying, well, we'll write it to the database because that's important. And then we'll publish something to Kafka and hope that they both work. And if not, we'll log something, right? It doesn't work, right? Distributed transactions in this way just do not work ever. They appear to work for the first month, and then it all falls down and you change company. So we don't want to do that again. I did not want to do that again. So Restate enters the chat. And I do want to say that while our usage right now is minimal, I don't have any terrible, novel, super exciting Restate usage to show you. I'm just going to show you some really simple things that solve challenges. But our plans are now grand. But it is already critical, and we want to do so much more. Now, the reason is minimal is I have been building this platform for many, many months now. But we experimented with different monolithic architectures for deploying RPC, which doesn't make sense in the current architecture of the broader system. But I thought that Restate was going to confine me to this. And then I realized, actually, no, we can deploy our handlers anywhere we want as long as we have a single entry point to that, which is where the kind of gateway comes in. We also, I say we, I am personally responsible for just force overwriting every deployment and not using generations. And that's because I wanted to, I thought I had to have a static URL for each service. But we're very lucky today with different deployment topologies. I'm using Deno deploy right now, where every time I deploy, I actually get a new unique ID for that service. So I'm no longer having to do that. But that did take a lot of experimentation because I was scared of going down that approach as well. I also started off with Cloudflare Workers here, but that has so many more challenges. Just getting the environment variables passed through was a pain and arbitrary code that I didn't enjoy. So, and I say screwed by GraphBase, no offense to anyone who knows GraphBase or the people that work there, but they recently sunset their entire graph hosting platform, which is where I originally hosted everything. So I've actually spent the last 6 weeks getting off of that platform entirely. Okay, so what about code? Well, let me try and not zoom in too much. Here's an example of our people service. As far as the data model goes, this is all nice and simple. You know, you have a drizzle schema, and you can see each of these services never really defines more than a handful of columns, and that's the way we want it. I don't want to ever run a migration. They always lead to danger and potential death eventually. This just writes to the Turtle libsql database. We have the read model, which is where we do the GraphQL aggregation. I don't need to show you that. But the write model is where we start to bring in the restate stuff. So we define a service inside of every service has its own write model, which is a restate service. Here we just have the ability to call a handler called create. We parse it using the same data model definition. So we're just spitting out these types across different services, which is very nice to use. If we get an error message, we return the error. It's nice. We write it to Drizzle. I'm not doing a lot of super resiliency idempotent stuff yet, but there are a lot of improvements I can make to this code base that I'm aware of. We do have a check just to make sure that the person doesn't already exist in the table. Again, returning an error message before eventually writing it and saying job done. Next, we have the shows host, because I think this is slightly more interesting. From a data model perspective, this doesn't store anything except for 2 IDs, which are living in completely different databases and completely different services. The read model is not important. The write model is now we say, okay, well, we've got 2 IDs. The validation here is going to be pretty trivial and they'll very rarely fail. But we do need to check that both of these people exist before we write it to the database. This is an overly cautious check. I could write it to the database and it could fail it further down the query path, but I didn't want to do that. So I make sure that, let's make sure that they don't already exist in the table and then writes them. I've not got to the other part yet. The way that this has been powered is by using step CI. At least some of the tests are being powered this way. So you can see we have automated testing, where we're calling our restate invoke function and then passing in the JSON and checking it. So we have like this nice, hopefully simple, easy flow that anyone could adopt for restate services and get things working. Now, the main use case that I was also going to show is that we have a situation where someone can sign up using our identity provider, which was Workhorse, it no longer is, but I'm going to show you the Workhorse version right now because that code exists. What happens is we get webhooks whenever someone registers and then verifies their email address. So I will say this is the old monolithic RPC directory approach, but I do have the newer version down here in the user service. So I'm just going to keep it in this one for convenience right now. We deploy the RPC service as an Astro application. And in the Astro application, we just have a restate URL, which is a wildcard matcher so that we can get every get and post. Oh, that's pretty big. And we just pass that and proxy it right through. As you can see, the env pass-through is mundane, so we don't do that anymore, at least we won't be very shortly. And we just pass this straight through. We then have unique folders for the events that we want to be able to handle. So this is the webhook receiver, and apologies, I'm going very fast, but if you have questions, I'll take them shortly. We have this registered webhook receiver, which comes from Workhorse, where we validate it's authentically from Workhorse. And then we're actually calling our handlers from Restate as user created and user email verified. Everything is super typed in TypeScript, which is very nice and fun to work with. And we have our ability to, these functions that we called above are really just workflow clients that are then trigger in the things that we need with the idempotency key for the user. So obviously a user can only have one ID, so we call registration once. And the verification is just calling a verified email that we have on top of the service itself. Lastly, we have the registered workflow itself. So, you can call run. I'm mostly just playing with the phases right now. I haven't found something. I'm just experimenting, really. But we have this promise where we wait. So we don't do anything with verification or sending email addresses until we get the signal for the verified email. And then we're hooking into resend to send a very crude text-based email to them saying, welcome to the Rawkode Academy, with the signal workflow function down here that just resolves that promise. Again, I don't think I'm showing anything life-changing, but for me, it has become a very important part of our infrastructure and more than one use cases, with a lot more, I think, to come. So while today it's minimal, tomorrow we want to roll out even more Restate and bring it into more of the architecture. So we want to bring in more workflows. I haven't even got to the fun stuff yet, is that when I would schedule a live stream, currently the old V1 system is all using pipe dream and very crude workflows, but they work. And I want to be able to just say, okay, here's a new live stream, which is the ability to create an episode in the GraphQL data model, all that stuff. But this relies on waiting for the people to exist, the technology to exist, the shows, the series. Like every distributed join has to be validated and verified first. And we're going to use Restate for a whole bunch of stuff there. But I'm actually wanting to experiment with using objects within Restate for every one of these resources, right? Every episode should be an object. Every person should be an object. Every technology should be an object. Because that gives us a new pub/sub mechanism where we can react to changes within the system, to the point where, if someone were to join me on an episode and then they log into the website and update their bio, why can't I go through every single YouTube video, update the description with their new bio? If we update the description of a technology, say I have AI write what is Restate and it's much better than what I put together, I want it to go and find every Restate video and update that description on YouTube and on the platform too. And I think objects will be a key delivery pattern for that. And of course, sagas. We plan to release courses very soon. So why not create a saga for when you start a course? We drip you content once a day. If you're falling behind, we send you reminders. If you've got passing and failing scores, we can give you resets and retests and all that things. Like we can hook in Restate to be the actual bedrock of our platform rather than just an RPC component as it stands today. Yeah. All right. That's it. That's all I got. I know I used more time than I said I would, but feel free to help out. The Rawkode Academy is open source. We have a Discord server if you want to chat about how to bring more Restate into things. I'd love to hear your ideas. Thank you for your time.